All right, so last section for us in chapter 11, this is 11.4, which is on shifted conics. And so as far as the shifting goes, we're really just talking about horizontal and vertical shifts, at least for this section, because we've already kind of, at least with parabolas, a lot of that was already vertical stretches or horizontal stretches. Um, So this is really just going to be um, the left and right, up and down shifts. And so we saw those earlier in the semester, and so you can refresh your memory on the rules here. So if you subtract from the x, we're going to go right. If you add to the x, we're going to go to the left. If you subtract from the y, um, we're actually going to go up, and I'll explain this as we go along. But the reason for that is, if you remember, when we did transforming functions, so if we talk about x squared and we added a k, that moved the graph up. Now in this section, we're, most of these are not going to be y equals something. In fact, maybe none of them are. But what we are going to see most of the time, if you move this k over, it'd be y minus k equals x squared. Well, that still has the same effect. It's still the same function. It's still moving up. So that's why um, the minus k is moving up and the plus k is moving down, because we're going to be on the same, we're going to have that k on the same side as the y. Um, so it seems like it's kind of the opposite of what we said before, but it's actually the same. We just rearranged the function that we were working with, or the equation. These actually are not functions, as we've talked about. So let's start with the ellipses. We'll do at least one problem for each of these types. So we talked about parabolas, ellipses, and hyperbolas. Um, so we'll kind of go through these one by one. So we have the original ellipse that we talked about in 11.2. So this is just the x squared over a squared plus y squared over b squared equals 1. If we shift this, so we move the center from 0, 0 over to hk, whichever, and it could be whatever direction. Then in the numerators, we're going to have x minus h squared and then y minus k squared. The a squared and the b squared are going to be the same. That doesn't change, because those are just numbers anyway. So you can't really do anything with those. Um, so we're really just talking about moving this. We're not uh, expanding this or stretching it in any way. We're simply moving it from the origin to some other point. And so then that moves this A um, will also, so this is a horizontal move. And so it's also going to move the vertex h units that way. So to find the new A, you would add h to the A. So we'll see how this works in this example here. So we have x squared, or x plus 1 squared over 4 plus y minus 2 squared over 9 equals 1. So let's see where this is centered. So the center of this would be, now we're going to change both of the signs of these numbers, so that these numbers tell us the center, the coordinates of the center. And so this is really, we need to think of this as a minus. So it's x minus -1. So that's why the x coordinate would be -1. And then it's y minus a +2. So but essentially, you can just think of it as you're changing the sign of whatever number is in the parentheses. So the center is at -1, 2, and then you can find the vertex or the vertices as if it was centered at the origin, and then you can figure out how you've moved and fix those as you would. So this will be a vertically stretched, so recall on the ellipse. whichever the bigger number is under, that's the way it's stretched. So this one's under the y, so we're going to be stretched vertically. And so all that means is the x coordinate is not going to change as far as the vertices and the focus points go. So the vertices, the x part is going to be the same because we're stretching vertically. So so if we want to kind of start to sketch this, -1 and 2, so there is the center, and then it's going to kind of look like this. So we need to figure out how long is this going to be? Well, we know how long it would be if it was centered at the origin, right? The length of this would be a, which is the square root of 9. So so if we were centered at the origin, we'd go up to 3 and we go down to -3, but we've shifted it up 2. And so that means that we'll subtract 3 and get -1, and we'll add 3 to the 2 and get -5. So that gives us -1, -1, and -1, 5. And so that'll be the new focus or the new vertices. So all you have to do to get that is figure out how long the ellipse would be if you're centered at the origin, and that's just going to be the square root of a, and then you're just going to add that and subtract it to the y, in this case because you're stretched vertically. If you're stretched horizontally, so we're coming out like that, then you would do that with the x coordinate, and the y coordinate would be the same. So then the focus points, recall the focus points are using c squared, which is a squared minus b squared. So 9 minus 4, so c squared is going to be 5, which means that c is square root of 5. And so to get these, again, the x is going to stay the same. Probably I should do that. X is going to stay the same, and then we're going to add and subtract c from the center. So we have 2 minus square root 5, and we have -1 comma 2 plus square root of 5. And that gives us our focus points, and that would be slightly under, not that it matters that much, you don't have to plot those really, but then the other thing we can do is we could see how wide are we getting this way. So square root of 4 is 2, so we're going to add and subtract 2 from the x coordinate, which is 1. So that would go over to -3, and then that go over to +1. And then there is our ellipse. But WebAssign, as you know, is going to be multiple choice for the graphs. So on this one with the ellipse, you're going to have 2 that are vertical, 2 that are horizontal, so you can automatically eliminate the 2 that are horizontal, and then probably after that you really just need to figure out which one has the correct center, because likely that's all you would need. All right. So this one, we are going to find the equation of an ellipse given shifted vertices and shifted focus points. So, so just to recall, now you can, so notice that the y coordinates are all the same. So the y coordinates are all 3. So that tells us that this one is stretched horizontally. So x squared over a squared plus y squared over b squared equals 1. And so you just need to figure out what a squared and b squared are. And so the way to do that, the center is going to be the midpoint of these two. And so really, let's find the midpoint between -7 and 3. So -7 plus 3, and then divided by 2. And so we get -2. And so that gives us the center would be -2, 3, because the 3 is obviously the same on both. So now how far? So if we have -2 there, we have 3 over here, we have -7 over here. What's the distance? That will tell us what a is. So a is going to be 5. So we have x squared over 5 squared, and then we can figure out what b is, because we can figure out what c is. So there is where the focus point is. And what is that distance? That distance is, well, actually this distance is 4. So the c squared equals a squared minus b squared. We have 4 squared, because the distance from the focus point to the center is 4, equals 5 squared minus b squared. And so we get 16 minus 25, so that'd be -9 equals -b squared. So b is 3, or b squared is 9. Doesn't really matter. Doesn't really matter what you write there. So we'll just write 3 squared, and so we have x squared over 25 plus y squared over 9 equals 1. Oh, that is not exactly correct, because we're not, this would be centered at 0. So we need to fix that. So we already found the center is -2, 3 up here. So this would actually be x minus -2. So we'll do x plus 2 squared over 25, and then plus y minus 3 squared over 9 equals 1. And that is what it is. So I forgot we had shifted off the center, or off the origin. All right, so those are the two ellipse problems. We'll move on to parabolas and hyperbolas next.